inequality is this. Quadratic, very good. And how do I solve it? What is the starting point? What do I have to write? Any suggestions? What do you think? Awesome, of course. I have to change it into a product. Very good. How do I factor this?
X plus 5 times 2.
Very good. And then I recommend, it's up to you. I accept the other methods, not plugging in and checking without showing work, but I accept the other method. I recommend this one, but it's up to you. So this is a chart that studies the sign of the product. X is the variable in the problem. It goes anywhere from negative infinity to infinity. And which values of X will I have to put in the chart? If I want to or not, it doesn't matter. They have to be in the chart.
0.
I only need the zeros of each factor. So when is this factor 0? Correct. And where is this factor 0? 2. So these are the only numbers, and they have to be in ascending order. So I'm going to write -5 and 2 because that's the correct order. Agreed? Okay. So there is a 0 somewhere in the row for x plus 5. Where is the 0 for x plus 5? Under... It's a silly question. Under...
Where's the what?
the 0. Where is this, when, for what x value is this expression 0? Perfect. Where is this expression 0? Very good. What happens to this product when x is -5 or when x is 2? Yes, because if you plug in -5, this is 0 times -7. If you plug in 2, this is 0 times 7, so it must be 0. If any of the factors is 0, a product is 0. We agree? Good. So what is the sign of this? Remember the end behavior? It looks like this or it looks like this. Which one? Or plug in a number. So between these two and then between these two. Plug in a number and give me the sign to the left of -5. What is the sign here? Plug in -10 and give me the sign.
Negative.
Plug in 100 and give me the sign. Plug in -10 and give me the sign. Plug in 100 and give me the sign. Good. So now we're multiplying. On the first subinterval, I multiply 2 negatives. Just the sign. Good. In the middle, I multiply 1 negative. Good. Outside, the last one, no negatives. Good. So then, now I'm looking and asking myself, what sign will I pick? I can only pick one sign. Which sign is a number greater than 0? Positive. So I look everywhere, I see positive, and I choose the corresponding x values. So x in the interval. Perfect. Yes, because it's not equal, I will use a parenthesis. And union. Very good. That's it. Okay. Any questions on this? Is this okay? Okay, let's pick a rational function now. Would you pick the type? And then I'll pick the function. Let's say type 1, type 2, type 3. Which one you prefer? Let me refresh your memory on what they mean, and then you choose. Type 1 has same degree over same degree. And this function has vertical asymptotes, depending on the function, 1 or 2 or none, depending on the function, and horizontal. The horizontal asymptote is determined by the leading coefficient over the leading coefficient. That's pretty much it about type 1. Type 2. Type 2 has higher degree in the denominator. Very similar to type 1, but the horizontal asymptote is 0. Always. And in type 3, and also vertical. And in type 3, vertical asymptotes, but not horizontal, but slant. Because the degree of the top is by 1 unit larger than the degree of the bottom. So, type 3, very good.
So type 2, the bottom.
The bottom is bigger, and degree of the bottom is bigger, so that's why the horizontal asymptote is 0. In type 3, there is no horizontal asymptote, but a slant asymptote. Because in type 3, the degree of the top is exactly 1 unit larger than the degree of the bottom. If the degree of the top is 5 and then 4, the ratio, the quotient is a line. And that will be the slant asymptote. Okay? Ready? Good.
Before you start, I have to leave. My son hurt his leg in his baseball game.
Oh, I'm so sorry. I hope everything is okay, and I'll see you on Tuesday then. My pleasure. So here's a type 3 function. Let's say x squared minus 2x plus 1 divided by x minus 2. Is it type 3? Yes, because the degree of the top is 2 and the degree of the bottom is 1. So the top is by 1 unit, the degree of the top is by 1 unit larger than the degree of the bottom. Good. Okay, so how do I start? For any function when I'm asked to graph, what is the first thing I have to worry about? Domain, very good, awesome. So the other thing that I worry about is potentially factor or simplify somehow. Is there anything that you would do to this function right away?
Just factor.
Very good. What?
X minus 1.
Very good. So exactly, awesome, very good. Perfect, perfect step. Thank you. Great. Good. So now I need to determine the domain. Can anyone give us the domain of this function?
Negative infinity, negative 1.
Careful. Why negative 1?
Oh, it's positive 1.
Why?
Because you said it was,
But why would I ever worry about the numerator of a fraction? I don't. I never worry about the numerator of a function, of a fraction. Can be anything. That is free like a bird. What is not free like a bird is the denominator is not free like a bird. The numerator can be anything on the planet. We never ever state restrictions for the numerator of a fraction. So then the denominator will be, the domain will be so I can write it. I have to put it up here.
negative infinity,
Correct?
2.
Exactly. Exactly. That's it. So once you put this in the chart, it's very clear to me that you know what the domain is. The domain is everything but 2. Perfect. So now what will you say about x equals 2? what will x equals 2 represent for this function? Say it louder. Very good. It's a vertical asymptote. So x equals 2 is the VA. Not the slant, but the vertical. Good. Once you say that, I'm hoping that you will immediately write infinity left and right. However, we don't know the sign. For the sign, I will be using 1.9 and 2.1. So let's plug it in. There is no point in plugging in the top any number. Why? Why I would not waste my time to plug in any number in the top? Because no matter what I plug in, what's going to happen to the top? It's going to be squared. So every time I square something, what do I always get? What type of number do I always get? Right. So don't waste your time to plug in anything in the top. So let's plug in 1.9 and give me the sign here. Very good. Please plug in 2.1 and give me the sign here. Good. We all agree? Good. So now I want the x and y intercepts. Let's plug in 0. This is easier here. 0, 0, 0. 1 at the top, -2 at the bottom. What do I put? Good. When is a fraction 0? Not when it's undefined. I already know it's undefined at 2. X cannot be 2. But when is a fraction 0? When the numerator is 0. So where is this? When is this numerator 0? For which x? You said it, Alex, earlier. For which x is this 0? 1, indeed. But since there are two solutions there, x equals 1 and x equals 1, multiplicity 2 for x equals 1. What does that mean? What will the function do at that point? If it's a multiplicity 2. Remember x squared. What does x squared do at 0? It's the same thing with what x minus 1 squared will do at 1. What will it do? It turns, right? Right? So multiplicity 2, this is a turn. We know that from polynomials, right? It must be a turn. It's a multiplicity 2 for a solution, like x squared equals 0. We have x equals 0 twice, right? Very good. So now let's determine the slant asymptote, and we are done. Ready? How do I determine the slant asymptote? Okay, I have to use the long division or synthetic division. So it's x squared minus 2x plus 1 and x minus 2 if you want to use long division. The quotient of this division will be the slant asymptote. Ready? How do I start? What is the first question here?
X.
Yes, indeed. X times x is x squared, and now I have to subtract. X times -2 is -2x, but I have to change the sign. It's mandatory. Nothing. And 1. I can continue. X times what is 1? So the division of x squared minus 2x plus 1 over x minus 2 equals, what is the quotient? The quotient is plus the remainder over the divisor. You can always check very easily. X squared minus 2x plus 1, and that's the top. So what is the slant asymptote? Y equals what? Only the quotient. That's it. The slant asymptote is only the quotient. So I go back to my chart, and I write y equals x SA, y equals x, SA, because that is also the end behavior.
So you don't have to take into account the remainder.
No. Let me tell you why. Let me show you why. Remember the slant asymptote, like the horizontal asymptote, refers to what happens at infinities, not in the middle. The middle doesn't count. So what happens at infinities? So in other words, the question here is, what happens to this expression as x approaches infinity? Well, this approaches infinity, but what does this approach? Remember from type 2. 1 over huge. Where does this go?
0.
Exactly. That's why this piece does not count when it comes to the slant asymptote, because it will always go to 0. So it counts when I divide. This is without this will be wrong. I have to put it there. In other words, this function can be presented like this. I can't delete this. But when it comes to identifying the slant asymptote, this piece goes to 0. It doesn't count. So that's why that's the slant asymptote. Very good question, Eddie. Thank you. Ready? So now I have to think in terms of the end behavior. So let's imagine, how do we graph y equals x? Is it this or is it this? And that's the end behavior. So what is the end behavior of y equals x? Is it like this, going from positive to negative, or is it like this, going from negative to positive?
Negative.
Right. So indeed, negative infinity to infinity. So let's graph what we have. So when we graph functions with asymptotes, what do I have to graph first? If I graph a log, or if I graph an exponential, or if I graph a rational function with asymptotes, what do I have to graph first? Always.
The asymptote.
Very good. So this function has x equals 2 as the vertical asymptote, and it has y equals x. Oops, I missed it. Almost. Y equals x as the slant. Good. I have to plot these points. 0 for x, negative 1/2 for y. 0 for x, negative 1/2 for y. And I have to plot 1, 0, keeping in mind that this will be a turn. So the function, it's coming from negative infinity, crossing the y-axis at 0, negative 1/2, touching the x-axis at 1, 0, and having a turn, and then dropping to negative infinity on the left-hand side of the vertical asymptote. One more time. From negative infinity, crossing the y-axis, touching the x-axis and turning and coming down to negative infinity. So here it is. In this problem, I don't have to find the local maximum. I know what it is, 1, 0. Now on this side, positive infinity to positive infinity, obviously it has to be something like this, and here there is a local minimum. And this is the function type 3, x minus 1 squared over x minus 2. Any questions? What about exponential equations? Are we comfortable with that, or we need exponential equations? Say it again. Yes. Do you want to choose one from this test that I just returned, or you want me to choose another? There was an exponential equation in this test if you want me to do that one. If not, I'll find another. Find one. Very good. So these are in chapter 4. Chapter 4, I'm looking at the end of the review of chapter 4. Review, chapter 4. Got it. Okay, so let's look at problem 70 on page 537. E to 12 minus 5x minus 7 equals 123. So I'm asked to solve this equation. First of all, I'm going to look at it and say, oh, I know, it's exponential. In the back of my mind, I always have three operations or 3 ideas. Factor, simplify, clean it up before I do anything. So what do you think I'm going to do in this case? First. Excellent. I need to clean it up. Very good. So this will be 130. Awesome. There is nothing else I can simplify, factor, or clean it up. Now there must be something else I can do. So what can I do in this case to solve for x? What will I think of doing? Awesome, to both sides. Which one?
The natural law.
Oh, okay, yes. If you remember, natural log has properties that no other function has. So I'd like to apply to both sides a mechanism that brings that power in front as a number. That is the function that will do that. Also, is the inverse function of the exponential. So bear with me. If I have, let's say the square root of x equals 2. So this is the square root of x. What will I do to both sides to undo the square root? Well, I have to square. Because x squared and the square root are inverse operations. What can I do to undo an exponential? I have to apply its inverse function. And that's why I'm allowed to do this. 12 minus 5x times natural log e. We don't write it anymore because we know it's 1. And the right-hand side is natural log of 130. Does it make sense now? So that's why when we have exponentials, we apply the inverse function, which is log. And when I have log, I apply the inverse function, which is exponential. That's why that important property, changing an exponential into a log equation and a log equation into an exponential, because they are inverses of each other. Here, that's my only chance. Now, if I want to solve the other way, right? So if I have x squared equals 4, what do? I apply the undo method. What is the undo? Taking square roots. Because x squared and the square of x are inverse operations. Same thing here. Exponential and log are inverse operations. Better? Okay, so then I have 12 minus 5x equals natural log of 130. And now this is linear. This is a number. It shouldn't bother us. And no, I will not evaluate it. So please don't do that. I will move 12. Negative 5x equals negative 12 plus natural log of 130. And I'll divide both sides by negative 5. So I recommend this minus natural log of 130 over 5. Or you can even write it like this. You're going to plug it in the calculator because no one can do this by hand. But this is better as an exact answer. But both are acceptable. Is this clear? Is this okay, everyone? Okay, so these were exponential equations. Do we want log equations or we are okay with log equations?
Did we do one other?
Oh, no, there was something else with expanding. No, you want to choose one? Or you want me to choose one?
Choose one.
Okay, so on the same page, 537, here is a log equation. So let's say 77, which is log base 3 of x minus 1 minus log base 3 of x plus 2 equals 2. Now there is a problem here because log is not a friendly function. And this is not a problem we had here. This is exponential. This is defined everywhere. No headache whatsoever. This exists, right? Exponential functions exist for any x. But here, this is a problem. Why there is a problem here is because log is not defined everywhere. It's a function with restrictions. So I will state the domain. Again, you have another option. Remember, you can say, I'm not going to state the domain, but I will remember always to go back and check. You have to use one or the other. It's up to you which one you prefer. I know some of my flaws, not all of them, and I know that I may forget to go back and check. So therefore, I prefer stating domain and finding the common domain. So what will you write? What is the domain? What do I have to write in order to find the domain of the first log? What will I have to write? What do I have to write in order to find the domain of log? Yes. I'm ready. What do I have to write for this?
X minus 1 is greater than 0.
Excellent.
X plus 2 is greater than 0.
Good. So this inequality means x greater than 1. And this inequality means x greater than negative 2. If you have any difficulty seeing which one is what, graph it. No units are necessary. I'm graphing it just to have an idea what's happening here. So this is 1 to infinity. And the other one is negative 2 to infinity. What is the common domain where both exist? Both logs, say it again.
1.
Very good. So common domain 1 to infinity, which means if at the end of the solution I get anything that is less than 1 or 1, what will I say? That the equation has no solutions. Right. Good. So now I'm back. Remember, you cannot touch the equation before you state the restrictions. If you condense the left-hand side and then try to find a common domain, it will be a different domain. So don't touch it before you state the domain if you decide to use the common domain. If you decide to check at the end, then you can go ahead and condense. So I want to condense this side. How do I condense the left-hand side? Can anyone tell us how to condense the left-hand side?
Well, base 3
Yes?
of X minus 1 over
Very good. Very good. Perfect. So now I want to undo the log. In order to undo the log, I will change it into an exponential. But how do I do that? How do I change this into an exponential? Yes. 3 squared equals x minus 1 over x plus 2. Awesome. Now I'm going to ask myself, after I write 9 or 9 over 1, my next question to myself is, okay, now what is this? And the answer is, what type of equation is it? And the answer is?
rational.
Very good. It has a ratio and has x in the denominator. Furthermore, it's a proportion, right? Perfect. So then I will cross multiply. 9x plus 18 equals x minus 1. Now, what type of equation is this? Obviously, this is the simplest possible linear. So I will move terms around. I will move x, I get 8x. I move 18, I get negative 19. And then I divide, and I get this. it's not done, right? I have to make a decision, draw a conclusion. What is the conclusion? What do you think? Anyone?
False.
Right, no solutions, because the solution has to be between 1 and infinity. No solutions. We call the equation a contradiction. We don't call it false. It's not incorrect, but we call the equation, the original one, a contradiction. Good. Will you redo all tests with solutions several times? Will you pick other problems from the problems in my math lab or problems in the list of questions and problems that I gave you on the first day of classes?